Hello, everyone. This is George Fahmy, the founder of Stakpak. So, I've built a couple of platforms myself before. I was a founding engineer at a couple of startups and worked full time on security and platform engineering in a couple of other companies. In my spare time, I like doing calisthenics, riding cruisers across like the country, and volunteering for the tech community, teaching people DevOps and programming from scratch. And also, I left two things, and they usually contradict, which is developer experience and security. But yeah, I love them both. And currently, I'm the founder and CEO of Stakpak. We're building intelligent DevOps tools for developers, including agents and a smart IDE for infrastructure configurations. But today, I'm not going to talk about Stakpak. I want to talk about our existing abstractions. So platforms are built on top of abstractions, like anything in computer science, like just layers and layers of abstractions. But why do you use abstractions in infrastructure? It's because we have tens of DSLs. So DSLs, or domain-specific languages, they make things simpler. So Terraform is a more succinct and like efficient way to describe cloud resources compared to just like writing, handcrafting JSON and making a lot of API calls or writing a lot of shell scripts to create resources. So DSLs make our life easier, but because they do make our life easier, and there's a lot of systems involved in like working or like building and operating a software platform, there's a DSL hell. We have tens of DSLs to choose from. And not only the syntax of DSLs are different, or like the YAML configurations, like schemas are different, but also there are a lot of hidden top secret knowledge in these tools and how they work internally. Like you can learn HCL and be great at it, but then you can't use Terraform because there are a lot of nuances for Terraform state and how different providers work that you need to be aware of. And this is top secret, heavily guarded kind of knowledge that only 3% of developers have, according to the latest Stack Overflow survey. So it's pretty tough to work with all these DSLs. So what we usually do is we build an abstraction on top of them. So DSLs make our life easier instead of handcrafting JSON to communicate with all the different infrastructure as a service APIs. But then when we're building platforms, we build a layer. We create a contract with developers and we stick to this contract. And regarding like different tools do this differently. Like we built an open source sort of CLI first platform engineering framework, and it worked with transformers. But like this is just like a fancy term to say functions that take like this developer contract and spit out configurations and do the other way around, like getting data from these configuration tools back to the developer contract. But the same thing works with Backstage or like Docker Compose files. You have a specific contract with the developers telling them how to define specific things in the DSL or a specific schema like Kubernetes manifests. And then there's some sort of data generation pipeline that takes these developer contracts and spits out low-level configurations like Docker files, Kubernetes manifests, Terraform code, or whatever. And then it's picked up by different tools, usually like tens of tools stitched together, and communicates with the API. So this is with abstraction. And what we do with these abstractions is we just expose a specific bit, like, or just a small interface to all the underlying workings instead of developers having to configure all these different DSLs and communicate with these APIs themselves. So what's wrong with that? Like it works great until it doesn't. So I spent the past 3 years interviewing hundreds of developers, platform engineers, DevOps engineers, support engineers, and engineering managers. And these three comments came up again and again and again. The first one is, for example, like developers have no clue what they're doing. This is mostly, you guessed it, like this is the infrastructure person or like the DevOps engineer. And they say developers have no clue what they're doing. And that's, of course, because like all of these tools have nuances or like top secret confidential knowledge of their internal workings that developers are not aware of, depending on the different platforms and all the different tools stitching together. Like it would be unrealistic to expect any single developer to have knowledge of all these different tools and how they work. I mean, even if you had an idea of how Terraform or Kubernetes worked at some point, these things change really quickly. Another sort of comment we get, like I got very often from infrastructure teams, is I spent 80% of my time on support tickets. So although we have this abstraction and it makes a lot of things like golden paths, it makes things easier for developers to do the regular stuff, I still get a ton of support tickets that I have to handle. So I have only 20% of my time to work on improving the platform and cutting costs, etc. And finally, there's another comment we get often is we need to push this, or like we need to push this feature, or we need to launch this. It's usually from developers and engineering managers, but developers or like the platform team has other priorities, which is to move to Kubernetes. So the platform team is trying to push to Kubernetes, improve the platform, but I'm trying to get things done. Like I'm trying to ship this, and I can't because they have other priorities, so conflicting priorities. So although we built great cool abstractions, we defined an engineering contract with developers to interact with this like complex platform and like hide away all the complexities and the gnarly stuff. We still have developers that have no clue what's going on. They still create a lot of support tickets, although they have a beautiful interface with Backstage, and there's still different priorities for developers and for infrastructure teams. So what's wrong with our abstractions? Like, why are they not working as intended? Why is there a gap between like developer knowledge and these abstractions in the first place? So one of the major reasons is like most of these abstractions are leaky. So back in 2002, Joel Spolsky wrote like created this like kind of law of leaking abstractions that says all non-trivial abstractions to some degree are leaky. But like, what does that mean? So let me show you a couple of examples. So a kind of leaky abstraction is defining limits, like or exposing limits to developers. If you expose these limits in Kubernetes to developers, you tell developers, okay, this is how you set the resource limits, and this is how you define the resources your app needs to run. But they don't know what happens if they exceed this limit. So this happened in production so many times. I can recall like like it's super painful that like a developer sets a limit and expects like the platform somehow to magically automatically honor this limit, but they don't know what would happen if they exceed this limit. So they end up with this like dreadful error of out of memory killed, and the application is just like killed because it exceeded the memory limits, and they have no idea what's happening. And this is a leaky abstraction because the abstraction promises to hide away all these gnarly details and what's happening and just like allow you to set the limits. But there's internal knowledge, hidden top secret knowledge within the tool and how Kubernetes work and how it sets these limits. So like the process manager would be able to kill this when it exceeds the like specified memory. So this is a leaky abstraction. Like it leaks this information, and developers have to be aware that if their process exceeds, like if their container exceeds this memory limit, it would be, oh, I'm killed. But they don't know that. Like it's hidden knowledge and it's not exposed through the abstraction. Another kind of like leaky abstraction is if you define a Docker file or like a very secure, very hardened Docker template that's used to Dockerize your applications. Or for example, you use cloud native build packs, which are amazing. Like they have standardized a way to containerize different applications, but they don't work for every single application. So you end up with corner cases where a developer requires some sort of OS dependency that didn't exist in your template, or requires different kind of permissions for these containers, for example. So your golden Docker file or your golden cloud native build pack script or something, like they don't work. So they can't containerize the application. And you need to break free out of the golden path and figure out this exception. So that's two kinds of leak abstraction so far. The first one is hidden behavior, which is what happens when Kubernetes kills the pods because it exceeded the memory limit, but the developer is not aware of this kind of platform-specific knowledge. And the other one is corner cases. So you build this platform to work, you build this Docker file to containerize multiple apps, but it stopped working because of a different specific corner case. A third kind of leaky abstraction, which like our developers don't face, but we as platform maintainers do face, is the changing APIs. So as we said, these abstractions are layered, and at the bottom layer is an infrastructure as a service or a JSON API. And this just happened with Google Cloud. Like they just changed the API, and suddenly your Terraform provider for Google is broken. And this is something you have to deal with. Like you expect this contract to be upheld, but it's not. And this is even harder for platform engineers because we integrate with so many different APIs on so many levels with a lot of different tools. So we can't expect them to stay static, similar to how you would like us to write a string library as an abstraction. So a platform abstraction is much harder to maintain compared to a regular programming abstraction like creating a string library. So the case I'm trying to make today is we need more intelligent abstractions. So we're just not going to throw away all our platform or existing abstractions. We're just going to make them more intelligent with new technology available, like LLMs, for example. Like I know this is like a bad word, like a dirty word for a lot of platform engineers in DevOps and infrastructure, but like just entertain the thought. Maybe there's something to it. So the architecture I'm proposing and something we've been trying now in production is creating more intelligent abstractions. So you see in this figure that is like the existing platform interface developers love, which is like can be a GUI, can be a CLI tool, or can be an API. And this falls back like or communicates with, triggers your internal tooling with the golden path. But what happens when the abstraction is leaky? Like what happens when there's an exception or there's unexpected change in your infrastructure or unexpected requirement from developer, or even the developer is not able to phrase what they need in the terms defined in your platform interface because it's hard coded by someone, then it falls into an unpaved fallback to an LLM agent. And this agent is flexible enough to choose what kind of internal toolings or APIs to call. And it uses your existing standard operating procedures, which you define for this intelligent interface. So instead of defining a rigid interface, you define standard ways of how you do things in English and steps. And the agent get access to these standard operating procedures to customize its behavior depending on your internal best practices and internal practices and how you organize code, for example, or how you do things in your organization. And it can read or access to infrastructure configurations, which it can do like dumbly, like how cursor or coding agents can do that, where like just search for terms in your code base, or you can do it in a more intelligent way, indexing your configurations and then giving the agent access to it. It also can get access to the infrastructure API, which is like a controlled way of giving it access to this API so it can fetch stuff live from your environment or your Kubernetes clusters. So you have your existing golden path UI with your platform, but then you can fall back to an intelligent agent that stitches together workflows on the fly depending on the use case. So even if the underlying tools are upgraded or changed, the agent will figure it out and then will tell you, okay, this didn't work because of that, and this is a workaround that you can use now. But in the future, we back these agents up, like we back these agent runs up to learn from them, generate new standard operating procedures, or create new paved golden paths. So instead of you manually having to circumvent your existing golden paths because they don't fit with every single use case developers expect to, you'd let the agent run, finish the task. If it's successful, you study the pattern or like how the agent execution trace, and then you create new standard operating procedures or update your existing standard operating procedures and take these agent templates and create new paved golden paths. So this is exactly what we used to do as humans. Is we do it once, we do it twice, we do it thrice, and then we automate it or create a golden path for it or like a specific button that developers can use. But instead of doing this ourselves, we give developers the ability to self-serve this through agents that integrate with our existing APIs and existing internal toolings and work exactly the way we do through standard operating procedures. And then we learn from these patterns and how these agents handle these tasks. And we update the standard operating procedures and create new paved golden paths. And this is not science fiction. Like this is something we've been working on for the past couple of years. And a lot of people have been working on this, trying to make it more reliable and more robust and trying it. So let me give an example of what this architecture what happens if you adopt this architecture in your environment. You can do something like this. Like I've been a security engineer for like at 3 different companies. And at some point I need to list, for example, here, like I need to list firewall rules which allow inbound traffic from any external IP, basically like something that allows everything to access my infrastructure. And because I'm a security engineer, I'm not a cloud expert, so I don't know what different cloud providers call firewall rules. And you would expect this from any engineer working on a team. Like they're not familiar with all the details of all the different tools or all the different techniques or the different cloud providers. So I just say firewall. And what happens here is like my intelligent interface scours, like this is not a hardcore case. Like we don't have a part of our platform that answers this kind of question, but I ask it as natural language and the agent picks this up, breaks it down, and then looks into the resources, like the possible resources on different cloud providers. So it checks my Terraform code, defining AWS resources, DigitalOcean resources, Google Compute Firewall resources in different parts of my repository, different repositories in my infrastructure, and then fetches things it think it's firewall rules. And it actually got it right. So in AWS, it got security groups, and DigitalOcean, it got firewalls, and in Google Compute, it got firewalls, and it figured out the rules where I don't define, like I don't fix the inbound IP, and I set it to like a wildcard and fetches these for me and tell me, okay, these are the rules that allow traffic from any external IP, which can pose a security risk, and you should probably manage these, or at least have a justification on leaving these allowed. So here, I didn't have this functionality available in my existing API, but it was possible because of a more intelligent abstraction. But then the elephant in the room is LLMs suck at DSLs. And this is proven by research. Like LLMs are not really good at, like they're better at very popular languages, and they're better with cases they see very often. But for things like infrastructure DSLs, they're not. But surprise, we can do a lot better than like the state of the art kind of like infrastructure tools that already exist, like or existing LLMs. We can make them infinitely better. And this is what we're working on and what other people are working on. So even if it's not Stakpak specifically, just Trust me when I say this, things are getting better, and people are building more robust interfaces around them. So I'm a huge fan of science fiction, specifically Isaac Asimov. And there's this really interesting quote in the iRobot series, which is like, you can prove anything you want by coldly logical reasoning. So if you pick the proper postulates, you can prove anything. So don't take my word for it. Just try it. Give it a chance. Try these more intelligent interfaces. Try and create some LLMs in your interfaces, in your platforms on top of existing tools, and see what your developers would tell you and see if it makes your life easier. Thank you. Please reach out by scanning this QR code, and I would love to chat about this.